Hi, welcome to Turkish Engineering. In this lecture, we are going to solve some problems for non-uniform motion. If we have some principles in our problems which are not introduced in introduction part, so I will just explain the new ideas for solving the problem, then I will solve the problem, okay? So I will complete some additional details in the problems. Okay, so in this problem, we have a graph. The graph shows the velocity of a motorcycle police officer plotted as a function of time. So it's asking the instantaneous acceleration at times when time equals to 3 seconds, 7 seconds, and 11 seconds. So actually it is asking what is my acceleration when time is equal to 3. Okay, so when time equal to 3, so I'm at this point, what is my acceleration? How can I calculate it? I'm just now giving you a new idea, okay? So if you have velocity if you have a graph of velocity as a function of time, you can calculate your acceleration by taking slope of the graph, okay? So slope of velocity graph, okay? Slope of velocity as a function of time will give me the acceleration, okay? Will give me the acceleration. So how can I calculate the slope here? Slope will be equal to rise divided by run, okay? And what is my rise here? It's just a straight line. If I'm going up or if I'm going down, I have rise and I have run. For example, if I'm going up, I have run by this amount and I have rise at this amount, okay? So I can just see what's my rise and what's my run and divide them to get what's my slope, and it will give me the acceleration. But in this if we have just a straight line, that means our velocity is constant. It is just 20 meters per second between 0 and 5 seconds. So in this part, when time equals to 0, my acceleration must be 0, right? Because if you take just some small section of 3 seconds, okay, just take this part between these and these points, you have initial velocity here and final velocity. They are equal to each other. So you don't have any velocity change. As I said, if you don't have any velocity change, your acceleration must be equal to 0. So let us put the formula. Acceleration when time is equal to 3, okay. So this is the first question. Let's say part A, it is part A, and this will be part B, and this will be part C. So in part A, let us calculate the acceleration. And its formula is velocity change divided by time change, okay. I don't have any velocity change, okay. I don't have any velocity change, so it will be 0. And it actually the slope of the straight line will be equal to 0. What about the second part? When time equals to 7 seconds. So let's just zoom, okay. I'm just here, 7 seconds. So go up, so you will be here, right? So your velocity at when time equals to just 28, for example, 28 seconds, 28 meters per second, you have velocity, but it's not asking about the velocity, it's asking about the acceleration. So as you see, from this point until this point, you have constant slope, just a straight line. If you know what is the slope of these between these two lines, so you will you can calculate the acceleration. So let us take the slope of this straight line to calculate the acceleration when time equals to 7. Or we can use this formula, okay, delta V divided by delta T. So V final minus V initial divided by T final minus T initial will give me just the acceleration. So delta V means V final minus V initial, and delta T means T final minus T initial. What is V final here? So I will just take 2 points which will be just in this straight line. For example, I can select this and I can select another point which is just, it can be 8 at 8, okay. But at 8 it's actually 36, or you can say, yes, let's say 36, okay. Our velocity will be 36, and here I have 25, okay. So our final velocity at this point, I have 36 meter per second. Okay, I have 36 meter per second minus my initial velocity when I'm at this point. I have 25. So I will put 25. What is my final time? Let's zoom. It is just 8, right? At this point, I have 8 seconds. At the first part, I have 6 seconds. So I will put my final and initial times. So my final time is 8, and my initial time is 6. So I will just get 11 divided by 2. Okay, it will give me just 5.5 meter per second square. It is our acceleration. Okay. What about the last part? When time equals to 11. So let's solve part C. When times equals to 11, you will be just in the last part, in the last straight line, but it is downward. Okay. So here 11. So I will be at this point. So I'm in this straight line. Doesn't matter in this point, any point which is will be in this straight line, acceleration will be constant because you have constant slope. So let's take 2 points. Okay, just if it's intersecting about just certain values, I will select the certain points. It will be just easier. So here I have 12 seconds and I have 10 meter per second velocity, and here I have 35 meter per second velocity, and our time is 10. So here my final point and here my initial point. Okay, so I will put the general formula. Acceleration will be equal to v final minus v initial divided by t final minus t initial. What is v final? At this point I have 10 meter per second, right? What is my initial velocity? At this point I have 35 meter per second velocity. What is my final time? Let's zoom. At this point I have 12 seconds. So my final time is 12. And our initial time, as you see, is 10 seconds. So I will get minus 25 divided by 2, which will be equal to 12.5 meter per second square. And this is our last part, the acceleration of the police officer when time equals to 11 seconds. Actually, this acceleration will be constant between this point and this point. Okay, so we finished this question. Let's move to the next question. So in this part we have a test driver, okay, in Incredible Motors, is testing a new model car having a speedometer calibrated to read meter per second rather than mile per hour. The following series of speedometer readings was obtained during a test run. Okay, so I have at each time I know what is my velocity, and I got these values from my speedometer. It is calculating a speed. It's calculating the speed for each time. Okay, so I know what is my velocity for each time. Compute the average acceleration during each 2-second interval. Is the acceleration constant? Is it constant during any part of the test run? So let's start by part A. Okay, I will solve part A first. So at each time interval, 2 seconds, I will solve for the acceleration. Okay, so I have here acceleration 1, acceleration 2, acceleration 3, or let's say this is our first interval, second interval, third, fourth, fifth, and sixth, and this will be our seventh, and this will be our eighth of interval. So I will calculate acceleration of the first interval, v final minus v initial. I can put v of, just say this is our let's put v final minus v initial divided by t final minus t initial. Okay, so I will put, what is my v final here? It is 0, right? And what is my v initial here? it is 0. I'm taking these 2 points. Okay, this is my first interval. So I will have 0 minus 0 divided by the time difference, and it is final time is 2 seconds and initial time is 0. 0 divided by 2 will give me 0. So acceleration in the first interval is 0. What about the second interval? It will be the same. Okay, it will be the same formula. So velocity has changed in this interval, as you see. So my final velocity is 2 and initial velocity is 0. My final time is 4 and my initial time was in this point is 2. So I will get 2 divided by 2, which is 1 meter per second squared. Okay. What about the third interval? So I will get acceleration 3, which will be 5 minus 2. Okay, 5 minus 2, the velocity differences, and actually the time difference always equal to 2, but here I have 2 minus 0, here 4 minus 2, here 6 minus 4. So always I have just 2 seconds of time interval. I will get 3 divided by 2, which will be equal to 1.5 meter per second squared. So as you see, acceleration is not constant, but let's calculate all of them. What about the fourth one? So acceleration of 4 will be equal to this interval. I have 10 minus 5 divided by 8 minus 6. So 10, our final velocity, initial velocity is 5, and it is our final time and it is our initial time. So I will get 5 divided by 2, so which is equal to 2.5 meter per second squared. So just continue. I will just put a line here, okay, for separating them. So I have A5, okay, the fifth interval, which will be equal to final velocity is 15 minus 10 divided by 10 is final time minus 8 will give me 5 divided by 2, which is equal to 2.5 meter per second squared. Actually, the acceleration in 4 and in 5 is equal to each other. Okay, they are equal to each other. Let's see in this part, going up 5, going up 5, going up 5. So these 3 will be equal to each other for acceleration. So acceleration in 6 will be same. It's just 20 minus 15 divided by 12. Okay, here I have 12 minus 10 will be equal to 5 divided by 2. It's just 2.5 meter per second squared. What about acceleration in 7? Actually, it is changing now. So here I have 22 minus 20. 22 minus 20 divided by just these 2 points, 14 minus 12. Okay, so I will get 2 divided by 2, which is 1 meter per second squared. So it is easy, just taking the velocities. And so as you see here, velocity is not changing. So acceleration in 8 actually will be 22 minus 22 divided by 16 minus 14, which is equal to 0 divided by 2, and it will be just 0 meter per second squared. And these are same, okay, when your acceleration is equal to 0. Make a velocity time graph of the data shown using case of 1 centimeter equals to 1 second horizontally and 1 centimeter. We just when I go up 1 centimeter, I must go to 2 meter per second vertically. Okay, just use this scale. Draw a smooth curve through the plotted points. Okay, by measuring the slope of your curve, find the magnitude of the instantaneous acceleration at times when time equals to 9 and 13 and 15. Okay, so we will make the graph. Then by using the slope, we will calculate the acceleration values. So just I will put the graph. It is our velocity and it's our time. So just I don't have a ruler here, but just I will try to sketch it. So here I have velocities. Okay, so and here I have time. So it will be just 2 second interval. Okay, okay, So let's put 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. These are our times, and here I will put our velocities. Okay, let's just make it 22. I have 1, 2, 3, 4, 5, 6. So let's put just 4. Okay, the scale will be, instead of this one, I will put 4 here, 8, and here will be 12, 16. I will put here 20, and here 24. Okay, so my first point, when time equals to 0, our velocity is 0. Our first point. Okay, I will just put the points here. So first point is here. What about the second point? The velocity is actually same as the first one, is 0 when time equals to this. So when time equals to 4, our velocity will be 2. So I will get 2 here. So I'm here now. When time equals to 6 seconds, I have 5. So I will be here for velocity, and for time I will be there. So this is my fourth point. Okay, what about the fifth one? So when time equals to 8, our velocity will be 10. Okay, our velocity will be 10. So I will be here. So this is our fifth point. When time equals to 10, our velocity is 15, right? So I'm just here. So this is our point. When time equals to 12, our velocity is 20. So this is the other point. When time equals to what? 14. Okay, 14. Our velocity will be just 22. Okay. Okay, so I have here point, and actually it will be constant because in 16 also will be equal to the same amount. So let us just make the graph. Actually it will be just, let's use this one. Then it will be just constant line. So this is our graph. Actually, maybe you will just draw it more beautiful than this one. So what about the acceleration? Can I calculate the acceleration when time equals to 9? Actually, that will be slope of this. As you see, from here to there, is just similar to the straight line. Okay, similar to straight line. So just take the values, okay, of 8 and 10, okay, between 8 and 10, you will take the average values to get the acceleration of 9. Okay, so just acceleration when time equals to 9, acceleration when time equals to 9. Okay, just put 9. Okay, so it will be equal to differences in 2 points for velocities and for time. My time interval is just 2. Okay, I will put 2. Okay, my time interval is 2, but my velocity change between these 2 points, between 8 and 10, is just between 10. Here I have 10, and here I have just 15. Okay, it's just 5. Okay, so it will be just as same as, approximately it will be same as this one. Acceleration of when time equals to 9, it will be same as this one, but it is going up, so it will be same as this one. Okay, so you will use the same idea to find the acceleration when time equals to 13 and when time equals to 15. You can just take the 2 points, which your point between of them. Okay, 9 is between 8 and 10. So when you're asking for 13, here 13, just take 2 points, 12 and 14. As this idea, you will calculate accelerations for 9 seconds to 13 and 15 seconds. So it is enough for this video. I will solve the other questions in the next video. See you.